data scientist at DLR Group. Thanks a lot for being on the show.
Yes, really looking forward to it. Excited to talk about some ML and AEC.
Nice. So, Benjamin, out of everything you could do in life, how you ended up in this position at DLR? What was your journey? How you navigated?
Yeah, yeah, totally. I mean, I think like most people who have kind of ended up in the AEC tech realm, it was a not a direct, obvious path. But I think honestly, from a really early age, I was interested in a few things. One was I was always really interested in architecture. Um, and like I would, I was a big like blocks kid, and I would like build these stadiums in my basement out of these blocks, and I was really interested in like, okay, how do I kind of engineer this? I have no glue, I have no nothing. How do I just get this thing to balance and build something cool? But and then I was also always interested in learning why things happen the way they do. So, and I think that second kind of interest um, took a lot longer to mature, and I had no idea what it was. I mean, when I was younger, I like data science was not a thing that people grew up wanting to be or to do. So I forgive myself for not knowing this is what I wanted to do at the time. um, but yeah, and then I kind of in um, undergrad, or kind of like going into undergrad, like climate and the environment became a really big passion of mine. And so I ended up going to the University of Southern California, and I studied this really interesting, in this and really interesting program called geodesign, which I still don't know to what extent anybody knows about geodesign, but it's essentially urban planning, policy, and architecture um, with kind of a spatial data component. So tools like GIS, ArcGIS, QGIS, all that kind of stuff. Um, and kind of the focus being, how can we use data to inform how we design? Um, and I certainly did not like come out of that program a data scientist, but I came out of it understanding the value of data, and I had pretty high data literacy, which was super valuable. And I decided to try to start a company right out of undergrad um, called Geo Impact. It was a great ride and totally failed, which is turns out to be just as good of an outcome in a lot of cases as it's succeeding. Because through that process, my goal was to I was trying to I was it was a huge goal. Really overstepped my capabilities at the time, but to develop a essentially, and this was in like I started this in like 2017. It's like it was the vision was like a sim city for real cities. Um, and so I wanted to develop essentially like a video game engine to represent um, kind of a sandbox environment where urban planners and policymakers could test out policies and kind of planning initiatives. Um, and I discovered we don't really know how these changes actually impact the world very well. Um, and at that time, the kind of amount of data required to crunch those numbers was just maybe starting to come online. I mean, I still don't think there's been a huge amount of advancement in this space, kind of around like urban impact modeling. There's definitely been some good stuff. There's tools like I think it's called like Urban Footprint. They do a really good job. But yeah, but through that, I discovered okay, there's this thing called data science and machine learning, and it lets you take a lot of information and find meaning and build predictive models and kind of like, I think the big thing is like define mathematically these kind of amorphous relationships um, that humans inherently understand but can't very easily articulate mathematically. Um, and that's how I became a data scientist, was through that process, and through all the trials and errors of trying to start that company. Then I went still kind of, on the sustainability trajectory, uh, joined a startup uh, who specialized in developing carbon credits based on changes in agricultural practices. So we developed some um, remote sensing um, kind of image segmentation models for that task. Um, that really improved my skill set, and then I joined Swell Energy, um, which was a startup developing virtual power plants. And so that I got really deep into like optimization and forecasting, and also just like how to develop a scalable data science infrastructure. It was a definitely, all of these experiences have been kind of many hat experiences. And so I think those experiences gave me a really good view of, all the components that are involved in machine learning and AI, not just the like fun, sexy stuff that you show. And then I got an opportunity, or I got, some a friend of mine reached out from DLR Group saying, "Hey, like we're trying to do data science and machine learning for real here. Um, there's not a whole lot of people who've done uh, machine learning who, like you were saying, who would then want to go jump into AEC necessarily. But it's been a passion area and a problem area for me that I think is really interesting. So it was an awesome opportunity and a good opportunity to kind of try to um, get some like really, I don't know, like kind of structure the kind of a data science team and a data science system from the ground up. So that was a pretty interesting, or it was an exciting opportunity. So I took it. And so, yeah, I've been here at DLR Group now for just over 2 years. Um, Always, still learning a ton, making mistakes, having some success. But yeah, that's kind of how I got here. So um, it's just kind of it's always been an interest area of mine. Um, but I think I realized through the startup experience that I really needed to truly understand the technology before I was really prepared to apply it to a new space. I think if you don't know the technology super well, it's not super hard to start trying to do it in a space that, the use cases are well established, right? But to try to apply a technology I didn't fully understand to an industry that didn't fully understand it, that was
Mm.
really hard. And so I think it just took some maturing. Um, and but now it's been really great since come a little full circle. So
And that's an amazing ride of multiple experiences. I'm curious to know, like, what was the biggest surprise from the data side you had while working at DLR? Like QGIS
Mhm.
and urban has its own challenges. AEC, a lot of people complain about unstructured data, but
Yeah.
they don't know how to convert that into useful IP. So,
Yep.
what were some surprises?
Yeah, I mean, I think, and this is kind of like what you just said, but is I mean, and I it's kind of the diversity of the data, I'd
Mm,
say, because there's like structured and unstructured, super valuable distinction, but also there's, you know, I think the way I look at it is just, yeah, it's like, is it like a super easy data type to use, or is it like a complicated data type to use? And there's ways to handle all of them. It just is, it's some are harder than others, and um, yeah, so it's definitely kind of, I think it's, yeah, the diversity of the data sets and um, kind of the in like intuited information that is left out of that data. And some of
Mm,
that intuited relation or information is relationships to other information, right? It's like, oh well, that one we keep in text in a PDF. Oh well, that we do it with images. Oh well, for that we do it, in 3D. It's like, okay, great. Now we gotta get these all to work together. So it's I think it's this that's my experience has been the same as a lot of folks. I kind of see it as a data set diversity requirement and
mm,
constraint, I think. Yeah.
I see. How does a week in your life as a lead data scientist look like? What are the different roles, responsibilities?
Yeah, totally. Well, right now we're the team's gone through you know some changes. We had somebody leave for a really good job, another really good job, a growth opportunity, which was awesome. We had to kind of backfill them, and then somebody is going on a leave, and so we have to backfill them. And we're also growing. So lately, a lot of my job has been hiring and resumes, which is that's a good problem to have. You want to be getting good people in the door. Um, and I'm about to share another a data science role that we're hiring for too. So if there's people who are listening to this
Nice.
who are interested in that, definitely kind of check out um, my LinkedIn, because that's probably where I'll post it. But so a lot of it is, I think once you start managing a little bit, your time is definitely taken up more with just um, the kind of management minutia, hiring, making, helping your reports with kind of their projects and scoping out what they should be doing and kind of the direction, really trying to hold the whole kind of thing together. But my focus primarily now is, which I really enjoy, is primarily on kind of the R&D research side of things. I do a little bit of client work. Um, there's a few kind of data products that my team's developed that we, provide for clients. And so like right now I am working on one of those. And so that takes up a chunk of time too. Um, but that's kind of, I try to kind of divide my time between, the management stuff, R&D, um, and then kind of broader strategy work as well. So it's kind of what it looks like.
Nice. And for someone who would be interested in working in this team, can you maybe share a macro view? How do you plan projects for a data scientist?
Mm.
Are they working
Yeah,
one project at a time? Do you plan quarterly goals? How do you?
yeah. There's a few things I'll say on that. One is, and I've talked to some of my other kind of colleagues who are data science managers, but like measuring progress in data science is really complicated. Um, it's a um, it's a line of work where you don't know exactly when your next breakthrough's coming.
Mm,
That breakthrough could very well be worth a ton, but you might just discover that it doesn't work, and you don't really quite know. I mean, with experience, you get better at knowing quicker whether which answer that's going to be. And so I think, and that's kind of what I focus on is um, I'm trying to I try to measure my own success and my team's success primarily day to day on like throughput of evaluation, right? It's like how quickly can we feel confident in our belief about some test we're doing. So like essentially like how fast can we prove or disprove our hypotheses? Because I think where you get in trouble in data science is when you um, spend too long um, not testing, essentially. And so, like, I think a really great person, somebody who'd get really high marks from me is somebody who's able, and this is what I look for, right, in interviews, was like somebody who's like, okay, here's the business problem. I can think of 5 ways this might work, and I'm going to come up with the 5 quickest ways that I feel like I can confidently test these. And then hopefully, that takes a week or two. We come back, we look at the results, we make a decision, we move on. Um, and that I think is the best way to kind of be making progress. When the reality is you don't know when it's going to work or how it's going to work necessarily. So it's more measuring on progress. Um, in terms of how we plan things, um, we we have kind of at DLR, in the design tech team at DLR, we have um, and I get it a little wrong, the right words, but the shape of this will be right. Um, we have kind of a now, new, next kind of goals framework. And so we want to be, the way I said it is I want everybody on my team ideally to be developing like 2 systems for now, right? These are things that are either already in production that you're improving and working on, or they're things that we're bringing essentially, quote unquote, to market this year. Um, and so I want everybody to be working on kind of 1 or 2 of those. Um, and, if it's something we're bringing to market, have that kind of be pulled off in the year. Um, then we have next, which is like the essentially kind of like MVP type work. So things that we feel like are really good applications, we just haven't tried them yet, and we need to know quickly, like, hey, could this turn into something we really deliver downstream? And so kind of I like for folks to be working on 3 of those kind of throughout the year. And um, then we have kind of our so I did now, and I think I knew is the one that I haven't said yet. But essentially, the third one is, you know, keep everybody keeping their ears to the ground, keeping up on the current kind of soda systems, and kind of doing just quick like presentations and tests of the soda systems um, to kind of demonstrate capabilities. And so the goal being that like the things that, these maybe 7 to 10 just super small test cases kind of funnel into things we might do as MVPs, which then funnel into things we might actually deliver um, to customers, to the company, to paying clients as well. So that's kind of how we plan things out. We haven't really adopted like a too much of like an agile framework. Sometimes um, if we're really developing like something that's going to be our product, which a lot of times we develop capabilities that are then leveraged by like the broader kind of development team. Um, but if we're really developing the product, we'll usually do kind of a sprint system around that product. But um, for the broader kind of research and development, we just kind of, we're not a huge team yet either, so we don't really do uh, agile. Um,
Mhm.
but yeah.
I see. And Benjamin, can you share few examples how in a project or a product you use, like, just to open up like ideas, like here's
Yeah.
how data science could help in various ways.
Yeah, totally. Um, well, I mean, I think like one. super obvious. Well, it was pretty. It seemed pretty obvious when we got in here, um, but is like with labeling, right? Like you need to understand like the function of spaces um, for engineering work, or and or space types for engineering work, and function of space for like code compliance. Um, and so we had a bunch of data that did have those labels, and we had a bunch of data that didn't. And regardless, somebody has to do that on every project. And so um, we have a set of models that, classify and infer those labels based on the information um, contained in those models. I think something that um, we're kind of looking at and working on right now is like in project recommendations. So we at DLR Group, we have a really uh, big data set uh, of past projects. And a common thing that folks do is they have to go find, hey, like I know we've done something like this before. Like, what did we use? Like, how did we design that? What types of fixtures should we use? Things like that. And so we have a system in development right now that kind of can understand kind of the context of where they're designing, right? It's like they can understand the like building type, the type of room that they're developing, kind of its relative position in space, um, some kind of like important design features, understanding kind of shape and things like that, and can then kind of find those sort of precedents in our existing projects, and show them like possible futures for kind of how to complete that. Um, so yeah, so that's something that's kind of exciting. Also, I think we talked a little bit about this in that kind of um, AEC meetup chat that you have and I'm a part of. But about like quickly, identifying details and similar details and what's different about details and things like that. Right? It's like we just try to find the stuff that's kind of boring,
Mm.
and we just try to help with that. Um, and I mean, there's tons of ways to apply. We also, we had, there's work around. I mean, outside of just pure architecture, there's work around like recommending different teams. Like these folks tend to work together and they tend to work together well. So like, let's recommend
Mm.
them. Or if uh, if this person can't work on this project, they have too much time scheduled elsewhere. What's the most similar other person we could plug in, right? And so that kind of gets into ops, but that's a problem that architects and architecture firms are dealing with every day. Huge problem, um, and you know there's existing repeatable, scalable ways for data science to improve uh, that sort of that sort of stuff. So yeah.
Amazing. Like each like of the ideas you mentioned has is tremendous task in itself. Like when you have like thousands of projects, like implementing it, even the small data annotation
Yeah.
or other strategies takes a lot of time.
Yeah, definitely.
Yeah. I was curious to know, do you follow a data hygiene or data standards? Like, for example,
Mm,
like even for designer working in multiple location, the way they label dining room might be different. But then when
totally.
you are doing like exploratory data analysis, like since just it's not labeled differently, you might not get an aggregated insights. And
Yep.
so schema standards, thoughts on that?
Yeah. So I've been trying to kind of spearhead um, groups to develop like room. or I guess it's like, you can kind of think of rooms, and I'm not an architect, so maybe but at least from a kind of from a functional perspective, like rooms, spaces, areas, pretty much kind of the same thing. And we do deal with a lot of Revit data, so some of this is going to be kind of Revit, like contextualized in Revit. But um, so kind of like a rooms ontology, a family's ontology, and a project type ontology. And that gets us really far. Um, and it's a really hard, but that's kind of our approach. Um, we and then we also have thing, right? We have some of the legal requirements around like function of space and space types and things like that. So um, we have some of that too, and that's kind of standardized. But I think it's like we're developing ontologies to handle that. And kind of the goal being the architects don't have to embrace the ontologies, but we want to be confident in our ontologies and in the meaning of our ontologies. And then we can use models to kind of infer between those for sure. Right? It's like for all of our data sets, we have what the architect called it, and then we have what we call it. And for the purposes of our analysis, we use what we call it. Um, but we know that like um, yeah, like a WC and a toilet is a bathroom, right?
Yeah.
And right, and there is true difference in those, but like there's far more similarity than difference. And so, right to your point, we want to be able to aggregate on that. And then we can still see, right, if we project it to like like an embedding space, that there's difference within those, but we can understand those differences there rather than
Mm.
having to use, right? It's like text as like a similarity metric is like way too disjoint. Like it,
Mm.
right? So we get around it. Yeah, totally. With we're kind of the ontologies and is kind of the way we're approaching that right now. But that's a really hard task. It's really hard to get folks to decide what they mean about something.
And I'm pretty sure this is a common problem all the big firms face, or like even like
Yeah,
every firms, like
totally.
because people change with time, their modeling, their annotation is always
Hmm.
changing. It's difficult to force standards in firms.
Right. Yeah, and I think that's kind of why, at least our current approach, which if we talk again in a year, maybe I'll say that this is a terrible idea, but is to like not force
Mm.
like those sorts of standards on folks.
You post
But
process it.
yeah, just do it in post. And then we know like really what we mean, and we're not nearly as reliant on people like following directions for our data to be good and
Nice.
usable. Yeah.
Nice. I want to pick your brain on this. Uh, do you think small or medium firms who don't have money to hire data scientists, but uh, low hanging fruits they can leverage? Or something?
Yeah, totally. So I think, right, the kind of the new paradigm of like foundation models certainly enables smaller firms to leverage to a certain extent um, kind of the power and promise of ML and AI. Um, I do think it's important to realize that um, you should be careful using these tools if you don't understand them. So I would hazard against people in smaller firms who don't want to hire a data scientist or a data science consultant or something, um, implementing AI on really business critical, like foundation model based AI systems on mission critical stuff. Like would, and this is, I don't know, I think there's a fair group of folks who are like me on this, but like I would much rather have a um, custom model
Mm,
than a like even like just like anything with like an LLM. Um, it's really LLMs honestly used for not non LLM specific tasks that worry me. Um, like even labeling is not really an LLM task.
mm,
Like people obviously people have done, can get it to work quite well, but it's, it can just make stuff up, right? It's like, would you trust autocomplete to do labeling? No, but that's what LLM is. So, just is be careful, but you can, right? And so I think that's what is really cool. You can kind of piggyback on all the data that these other companies had, um, to use some MLAI yourself, which is super cool. I think, things like, you could, if a smaller firm wanted to try to use like grounding dyno to do object detection, like that's a totally, valid use case if you just start like trying to automatically find all the windows that look like this,
mm,
right? Like that's a low risk, use case. You could pull that off the shelf for sure. Do that. But I would say a word of caution is if you are if what you're doing being wrong is a problem, then I would I would be pretty reticent to just try to like pull down a foundational model and do anything without just like spending a lot of time to learn about how these things work. I think you can get into a lot of trouble pretty quick. So,
mm. Do you think like one could bucket like okay, $0 to $10,000 data science experiment, 10 to 100 grand and more? So maybe
mm,
like grounding dyno, if you spend like have an engineer tinker with APIs or set up yourself, like it's smaller ticket experiment, doesn't need much money, but there could be higher, like some experiment could take 6 to 9 months or more just to validate the hypothesis which you were aligning. So I'm just thinking like those firms maybe think, okay, what is the ROI? How can we quickly
yeah,
validate this money? And they might not have budget for 50 grand experiment, but kind of.
yeah, yeah. I mean, I think right. I mean, I think like constraints are really valuable, right? Like if you know you can't spend a ton of money, like, and this is kind of like my like part of my philosophy, right? With how I think about data science success in general. But like, if you kind of if you have a problem or a handful of problems and you want to start testing things, you can use that like budget requirement as a constraint and say like this could work, but it's going to take a really long time to test, so like let's ignore it. And that like more quickly helps you find the valuable solution that's quick to test, which is probably a better, yeah, that's just like a better plan in a lot of ways. Like I almost would always want my tests to be under $10,000. I mean, like that's, you, but I mean, I guess there's part of that is like maybe the experience side of it is it's easier maybe for folks who've been doing it for a while to tell if it's going to work quicker. But yeah, I would say like you definitely don't need to spend a ton of money to try it.
Mm,
I think where the money comes in is productionalizing it in really, right? Because it's like, well, cool, I can do this. I can prove that this thing works. Like I tried it 100 times. I paid Open AI like $2 to try it 100 times. But it's when you now run it on, if you run it every day on, every 5 minutes, now you're paying, $100,000 a month. And that's like where the cost really comes in, is when you start scaling, in my experience. So I think you can test pretty cheap. Um, so yeah, I guess that's my reaction to that. 'Cause I would don't, yeah, if you're a small firm, like, don't, even if you're a big firm, don't do $100,000 test. Just not,
Mm.
yeah.
Yeah, yeah. Because like as you said, right now LLM and foundation models have like lowered, like initially like in the GAN era or
Mhm.
other, you have to spend a lot of time in data set curation,
Mm.
training. So it's a longer period of to test whether for this task. Now a lot of these things can do zero shot or one shot
Mhm.
way of teaching a new task, although compromise on the accuracy.
Yep.
But there are way cheaper ways to validate an idea of for particular annotation, classification, task.
Hmm.
Even like I was testing the other day, like YOLO models, even with smaller, like in MBs, with 200 of your dataset images can perform really well rather than out of the box like solution.
Yeah.
So it doesn't take like you can do those training on free on Google GPU. So if you know, like maybe that's why having maybe a consultant or someone who knows that space, because if you hire a data scientist and they'll like it's a dead cost at least for a year or a few
Right.
years. But again, how can we cheaply like in validate that idea rather than like
Yeah.
having those.
Yeah. Um, yeah, totally. The other, and I guess I don't, I'm actually, I haven't, I worry about with, like, the fine tuning on small data sets. Again, it like shows a quick win, but I'm still not super sure how well it scales, right? It's like it's still learning on a small set of information. Um, Obviously, it's still leveraging all that pre-trained information too, so that should help. But um, yeah, I think, yeah, yeah, I right. It's like, also, it's, scaling with those models it depends on if it's an open source and you can host it yourself. That could be great, but they're also
Mm,
often a lot bigger than they might need to be.
yes.
So, like, there's costs to it. It's like the trade-off is quick test, cool example, and the cost is really big models, scalability and accuracy. So,
Yeah. Yeah, personally I feel uh, a lot of times when people have these experiments, they have a adoption issue. Like uh, if people are like using every day, I think that's a great success or win, and then
mhm,
maybe invest more on okay deploying on your own infrastructure. I think we
yeah,
are still figuring out. We haven't I haven't personally seen many applications where, oh, we did this fun experiment with AI now from now everyone is using, but it's thousands of dollars in open AI bill.
yeah,
But still
yeah,
I think we haven't cracked that.
yeah. Well, and yeah, to your point, yeah, then you can say, okay, well, now I have all this. I've now essentially paid OpenAI for all of this data on the relationship between my inputs and my outputs. Maybe I should now just train a model
Correct.
to do this thing, right? And so, yeah, I think that's a good way to look at it. I like that. Um,
Yeah.
yeah.
uh, and building on your point of like uh, earlier you were alluding that okay fine tuning might work on like the small scale, but in
Hmm.
production or you haven't you don't know how scalable and good it is. uh, so I've been like developing systems for like continuous training,
Hmm.
monitoring edge cases, failure cases, and continuously improving model. What are like your frameworks of like monitoring or systems in place for data science experiments?
Yeah. I mean, we're honestly, so, well, on the one hand, for a lot of our data engineering, we use Airflow. And we I've developed systems in the past to do kind of automated retraining and things on Airflow and monitoring through Airflow. So I think that's kind of like our most comfortable home base. Um, but the other thing, and I'm definitely interested in kind of how other folks have approached this, but um, um, a lot of our information is not like tabular, and even isn't like image based. Um, Sometimes it is image based, right? You can encode things as images, but um, and um, I've found a fairly big lack or kind of like dearth of or no kind of lack of like existing platforms for doing, right? Like we're doing a lot of like graph based work, right? And it's like can't really like use SageMaker super well for graph
Mm,
models. At least that's my experience when I was looking at it, or like Databricks for that. And so honestly, we've been doing that stuff a little bit more by hand. Um, the kind of monitoring and retraining. The other thing is a lot of our stuff isn't like scaled to tens of thousands, hundred thousands of users where we don't get good feedback from them. Like if something's going wrong with our systems, we hear pretty quick because a
mm,
lot of it is like for internal use. Um, so yeah, I would say we don't have a super robust like experiments and monitoring and kind of like automated ML ops um,
mm.
process at present. I think as we mature, we might need it. Um, but yeah, I think we kind of we for that stuff we do a little bit. We're a little bit more hacky, and I think I think it's kind of because a lot of times we're developing our own models. We're developing kind of our own relations between these different types of data sets. Um, and it's sometimes just easier to like, this is the code that does it. So like, let me just put it on a Kubernetes cluster instead of like try to get it to work, if that makes
Mm.
sense, in an existing kind of platform. Um, yeah, we develop a lot of like custom Kubernetes stuff to kind of scale. Um, but yeah.
Amazing. I would like to touch on like you had some very interesting insights on the discussion in the group regarding like details embedding, why we need to train.
Mhm.
So it would be great if you can.
Yeah.
Yeah.
Well, yeah. So like, I think something that we need to like the first task for like AEC in the world of ML is we have to actually understand like we have to teach computers how to understand what we're talking about. Um, and like what architects and engineers and designers are talking about. Um, and our data is not like everyone else's data particularly, right? Our data's are drawings, our data are diagrammatic, our data um, are relational, right? Like a room is not a room necessarily. A room could be like like right at a most basic level, a room is floor, ceiling, and walls. But that's not always how people experience a room, right? Like if I have an open floor plan, I might experience my kitchen separate from my living room. But if we just rely on an image, that's totally lost, right? Similarly, if we just rely, even worse, if we just rely on a like an image model that understands full color imagery in 3 dimensions, it's going to have no idea what it's really looking at and the importance of line weight or like any of this stuff in a diagrammatic image. And so I think, right, like in these other industries and in like kind of full color imagery, even in audio, um, in text, certainly, like people have done a lot of pre-work on how to have a computer understand this information, and um, and we haven't really done that very much yet. So I think that that's really where focus, at least where my focus is, like what do we mean and how do we convey that to a computer? Because that's how it can learn from that. And so, I've been looking, you know, certainly like I think just an image, and this is what I was saying on that call, but like um, an image encoder that's trained on tasks related to, d- you know, um, like detail related tasks, or at least like, where it's inferring information about sketch and detail and diagrammatic information, right? Like that, we kind of need to do that if we want to really trust and have high performance out of those embeddings. Um, Similarly, right, like we're looking into and we're doing work on representing all of our spaces as graphs. And I know I've seen you do some of this stuff too. But like graphs are a really great way to represent architectural information because the meaning of a room or of a piece of furniture is not fully encapsulated in its attributes, right? It's like it's in its relation to the other stuff, um, right? You lose like you lose all the design if you don't include all of the relationships, because design is about relationships. um, you need something here in open space here to balance it, and like all that stuff is encoded in the relationships, and graphs can encode that. So yeah, I think it's like bef- a little bit before we get like super excited about like all this stuff we can just pull off the shelves. For if we really want it to perform and we really want it to impact our industry, we have to start at the same place that all the other industries started at.
Mm.
Um, and um, that's a lot of hard work. It's a lot of data set collection. Um, Creating embedding models seems really boring compared to the other stuff, but it makes all the other stuff possible. So yeah, so that's yeah, I think that's what I'm most focused on and most excited about and interested in right now. It's just like how do we actually communicate mathematically what's happening in architecture? Um, yeah.
That's a exciting, challenging, and resource intensive problem. Like I think like we always look at the downstream applications which are built. We're like for having a good core foundation which it like
Mhm.
inherently understands our domain
Yeah.
and can do great wonders rather than like just brute forcing fine tuning another encoder that okay just work for our task and like okay, just squeezing the stretch or heck out of that model just for that task. You need a
Yeah.
different ground up what would be the training set look like, or like what are the labels like? I'm just you mentioned
Yeah.
graph also, like details itself can be represented in multiple ways and hierarchy and everything like yeah.
Yeah. I mean, I think that's still like an outstanding question, right? Like
Mm.
that's the question. We need to figure out and we need to test and evaluate those methods, and that's what we're trying to do here. Um, but um, it's not obvious, which makes it hard, but it also makes it potentially super valuable, right? Hard work is valuable work. Um, and Yeah, I mean, I think in some cases it's obvious, right? If you want to create a room graph, right, use adjacencies. Okay, that's pretty good. If you want to create a floor plan graph, like with furniture layouts, starts to get a little harder, right? If
Mm,
you, so you want to have multiple stories that communicate together. Now you have, maybe you have like HVAC that's going through multiple rooms, right? So, but I think what's so powerful about graphs is there's the flexibility to represent that. And then the question is just, okay, like which are more performant on your tasks? And can we find good representations um, that are highly performant on a lot of tasks? Um, so, but and you can do really right. Like the thing about embeddings, right, is like the task that you're using to train the embeddings doesn't have to be complicated in itself, right? There's
mm,
some great work on using it to essentially just create an adjacency graph, um, and then use like graph features like things like node degree, centrality, um, page rank to and you just use those features then to predict. Um, you just do a classification of like the room type, right? So it's like super simple from like a output standpoint, but then the embedding layers in there are highly descriptive of the spatial relations of the rooms, and so now you can do clustering and start to really see like, oh, like corridors are really different from rooms, or from bedrooms, and bedrooms are really functionally different from kitchens. And you can say, hey, like this bedroom and this office are called different things, but they're actually really similar to each other. So like, hey, if we need another bedroom, like this is a great thing to use. And so now we're really actually starting to understand architecture,
mm.
not like, I don't, it's like this is how architecture actually works and how people think about it. And the computer is now thinking about it in the same way. And so we're starting to like see improvement, right? Teach, if you try to use an LLM for architectural tasks, it's understanding architecture in the way it understands Shakespeare. Like, I don't know
Mm,
if that's what we want. So it's,
yeah.
that's kind of my philosophy on it. And I think, it's starting from a little bit more first principles. Um, and, luckily DLR Group is like, you know, wants to get this right, and do it really well. And so they've created the space to try to do this, which is excellent. Um, I know that not everybody has that freedom, especially if you're in like a smaller firm. But I think these are the really interesting questions and the ones that will like open up um, actual kind of growth for AI and ML and AEC. The boring stuff, as always.
Yeah, yeah. I know it's almost uh, an hour mark. What is your piece of advice to budding technologists who want to become a data scientist in AEC, and like
Yeah,
resources,
I
learnings, everything? Yeah.
totally. Yeah, I'd say just jump in. Uh, it's not gonna make sense right away. That's fine. Uh, every week I read something that doesn't make sense, and then you just got to read it again, and you got to try it, and then it starts to make sense. So, just if it doesn't make sense, but you're still going, you're doing it. Um, and and you do have to like you do have to learn to code. So if that isn't a skill you have, you know, go to Udemy, um, go to Coursera, whatever go to YouTube. Tons of great YouTube stuff, right? And just get started with it. I found it most helpful to like I'm I'm always like that. I learn best through projects.
Mhm.
So I'd be like, how do I code I don't know, like a calculator, right? That's a common first one. Or how do I code a little game, like how do I code Snake, things like that. Just getting used to it, getting some quick wins, because that's, you're just doing Snake in more and more complicated ways as you keep going, right? The core of it stays the same. So whatever you can do to kind of get the wheels turning without like discouraging yourself. um and yeah, just and that but and I would also say I would, and I guess this is just my general position, but I'd hazard against the like the mentality of I I don't need to understand how this works to use it,
Mm,
which I think is like a really easy thing to start with. And that doesn't mean you can't use it before you understand it, but I think it's good to remember that like if you then do learn to understand it, you're gonna be able to use it better. And it's a good idea to circle back and really get into the nitty gritty, I think, um, of how the systems work, because that's how you can differentiate yourself. That's how you can do something new, right? With if you don't have the understanding of the underlying systems in mathematics, and you're not going to know the underlying systems in mathematics of all of it, but it's like if there is a space in this that you really like, the way that you can then do something new and better is by understanding the underlying systems in mathematics. So if that is the kind of thing you want to do, if you just want to, take stuff off the shelf, use it, cool. But we definitely need a lot more folks who are kind of getting deep into stuff. And there's definitely a lot of opportunities for that, I think. So, and there's tons of unsolved problems here. So, it's ripe for research. Though there's tons of great research going on too, but there's still tons of stuff to learn. So, yeah, I'd say, yeah, YouTube is great. YouTube University, um, huge fan. Absolutely one of my alma maters. Um, and yeah, just enjoy enjoy learning through making mistakes and finding stuff out. I mean, I part of the reason I like this job is because I learn something new every week, um, and um, I think that's really fun. So yeah, I think that's my advice.
such a great way to end the interview. It was
Yeah,
lovely to know your journey, the kind of work you're doing. I think the DLR Group is very rare among the industry, pushing the boundary and doing this kind of things. So I appreciate
yeah.
your time
Thanks,
for
man.
doing this. Yeah.
Yeah, thanks for including me. Yeah, I do have I have a newsletter that I started recently. So for folks who are interested in kind of like understanding the underlying kind of mathematics and minutia, you can check it out. It's called Not Magic, Just Math. You can find it on my LinkedIn. I post about it like every week. But yeah, I'm gonna start kind of jumping into some architectural topics too. Kind of started with like optimization. And I'll cover all kind of the I'm covering all the kind of core kind of typologies of machine learning and the math and systems required for them. So if that's something you're interested in, definitely check that out. Yeah, thanks so much
Ama-
for having me on.
Amazing. Definitely gonna subscribe to the newsletter,